we are covering the conventional drinking water treatment train for the FE civil exam. This topic is conceptually important and also shows up in calculation-based problems. The standard treatment train for surface water follows a specific sequence: coagulation, flocculation, sedimentation, filtration, and finally, disinfection. The exam will test your knowledge of what each stage accomplishes and the key parameters involved. It starts with coagulation, where a chemical coagulant like aluminum sulfate, also known as alum, or ferric chloride is added to the raw water. These chemicals are positively charged and neutralize the negative charge of suspended particles like clay and silt. This neutralization is the critical step that allows the particles to start clumping together. This happens in a rapid mix tank to ensure the coagulant is dispersed quickly and thoroughly. Following coagulation is flocculation, which is a slow mixing process. Here, the destabilized particles are gently stirred to encourage them to collide and form larger, visible clumps called flocs. The exam often creates confusion between coagulation and flocculation. Remember, coagulation is the chemical charge neutralization with rapid mixing, while flocculation is the physical process of building flocs with slow mixing. Next, the water flows into a sedimentation basin. In this quiescent tank, the heavy flocs settle to the bottom by gravity for removal. After sedimentation, the clarified water passes through filters, typically made of sand and gravel, to remove any remaining fine suspended particles. The final and most critical step for public health is disinfection. This process kills or inactivates pathogenic microorganisms. A key concept here, and a frequent topic for exam questions, is the CT value. CT is the disinfectant concentration in milligrams per liter, multiplied by the contact time in minutes. Your NCES FE reference handbook contains tables in the environmental engineering section that list the required CT values to achieve a certain log removal of pathogens like Giardia cysts under specific conditions of temperature and pH. For example, a problem might state that for 3 log inactivation of Giardia at 10 degrees Celsius and a pH of 7, a CT value of 95 milligrams minutes per liter is required. If the chlorine residual concentration at the exit of the contact basin is 1.2 milligrams per liter, the required contact time T would be CT divided by C, which is 95 divided by 1.2, resulting in approximately 79 minutes. A common exam trap is to provide the theoretical detention time of a basin, calculated as volume divided by flow rate, along with a baffling factor, often expressed as T10 over T. This factor, which might be 0.7 for a moderately baffled tank, indicates that the actual contact time is only 70% of the theoretical time due to short-circuiting. You must use this reduced actual contact time in your CT calculation. Another trap is units. Always ensure your concentration is in milligrams per liter and time is in minutes to match the CT tables. A useful mnemonic to remember the process order is clean, floc, settle, filter, and disinfect. For coagulation, flocculation. Sedimentation, filtration, and disinfection. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.